Hi, I am Sanjay Patel. Today we are going to derive the equation of right circular cone in this lecture. So first of all, let us understand what is right circular cone. I will first write the definition of right circular cone and then I will explain using the figure. So the definition goes like this. Let capital V be a fixed point in R3 and let capital L be a fixed line passing through the fixed point V in R3. Okay. Now let small l be any line. This is a variable line or arbitrary line. Let L be any line in R3 passing through V and making an angle theta with the fixed line capital L. Okay. Then the surface generated by revolving line L about the fixed line capital L in such a way that the angle between the small l and capital L, the variable line L and the fixed line L remains theta, remains the same. This is known as a right circular cone. Is known as a right circular cone. So this is our definition of right circular cone. Let us understand what is the meaning. This says we take a fixed point V in R3 first. Say this is a fixed point. Okay, and take a fixed line passing through this fixed point. So let me take a line passing through this. Okay, this line is passing through the point V. Okay, so this is my fixed line capital L. Now we take another line in R3 so that the angle between this line and the fixed line remains theta. So let me consider this line small l so that the angle between the two is theta. So yes, this angle is theta. Now we revolve this line L about this fixed line capital L in such a way that for all the positions of the line L, small l, the angle between this line, this variable line, this is a variable line and this is fixed line. that remains constant. So as a result, what happens is we get a surface like this. Say, let me use so the angle between these two remains the same angle theta. Okay, so the base curve of this surface will be circular, something like this. Say it will be a circle. What happened? Okay. Let me keep this circle over here. Fine. So if we rotate the line small l, which is a variable line, about the fixed line in such a manner that for all the position of the line small l, the angle between the two lines remains theta, then such a surface is called a right circular cone. Okay, and this angle theta here is known as the semi-vertical angle. This angle is called semi-vertical angle of the cone. Semi-vertical angle. And this fixed line, this is known as axis of the cone. And this variable line is called generator of the cone. Okay, and this point, as you know, is always a vertex of the cone. Okay, and we want to obtain the equation of such a right circular cone. So let us write this as a theorem first. This is a very important result. Obtain the equation of a right circular cone having vertex at the point, say v alpha comma beta comma gamma. The axis is the line given by x minus alpha upon L is equal to y minus beta upon m is equal to z minus gamma upon n, and the semi-vertical angle is theta. So you want to find the equation of a right circular cone where the vertex, the axis and the semi-vertical angle of the cone are given. So let us prove this. I will use the same figure. So let us copy this figure. Let me copy this. And keep it here. Okay. So first you must draw the figure, and let me modify this. This is, I don't want. So let us remove all such things. Okay. Fine. So consider a right circular cone as shown in this figure. We are given the equation of the axis here as x minus alpha upon L is equal to y minus beta upon m is equal to z minus gamma upon n in the theorem. The semi-vertical angle is theta and the vertex, this vertex is given by alpha, comma, beta, comma, gamma. So coordinates of this vertex is alpha, beta, gamma. And this axis passing through the vertex, and it is obvious that the direction of this, this line is given by L, comma, M, comma, N. Okay, I want to obtain the equation of right circular cone. So what I will do is, I will start with an arbitrary point on this cone. So let P be any point on the cone whose coordinates are x, y, z, which are variable. Since P is on the cone, it lies on some generator of the cone. And we know that every generator is passing through the vertex. So the point P lies on the generator Vp. So the direction of this generator, I can say like this. The direction of this generator is given by, say, if we call it x bar, then it is same as the direction of the vector, say, PV. It is same as the direction of the vector PV, which is nothing but x minus alpha, comma, y minus beta, and z minus gamma. P is this point and V is this point. So I can take the direction of the line Vp as the position vector of the vector Vp, PV or Vp, anything. And the direction of this axis, we know that is given to us, direction of this axis that I want to call y bar, and that is given as L, comma, M, comma, N. Okay. So let us write something about this. Let Px, comma, y, comma, z be any point on the required cone, or on the required right circular cone, required right circular cone. Okay, since V alpha, comma, beta, comma, gamma is a vertex of the cone, this Vp is a generator of the cone, okay, and therefore I can take the direction of this, therefore the direction of the generator is x bar, let me write in the new line, is, say, x bar. We already discussed this thing, so now I can write this as x bar is equal to x minus alpha, y minus beta, and z minus gamma. See here, in this P is a point x, comma, y, comma, z. The vertex V is alpha, beta, gamma. So the vector Vp is given by x minus alpha, y minus beta, z minus gamma, which I am calling x bar. And that x bar is the direction of this generator. So that is first thing. Okay. Now, another point I want to mention here is the direction. Now, the direction of the axis of the cone, is, that is also known to us from the equation of the axis which is given in the hypothesis. It is L comma M comma N. It is this line whose direction is L, M and N. So I can put it here like this. Y bar, I am calling the direction as Y bar of the axis, and that is L, M, N. Okay. So we have obtained the direction of the axis as well as the direction of the generator line. And what is theta? Theta is the semi-vertical angle, and by definition of the right circular cone, we know that the semi-vertical angle theta, that is this angle is the angle between this generator, any generator of the right circular cone, and the axis of the cone. So we can use that fact to find the value of the angle theta. So let me write here. By definition of the right circular cone, the semi-vertical angle theta is the angle between the axis and any generator of the right circular cone, Okay. Therefore, this theta which we are mentioning, this theta is the angle between the two vectors, say x bar and y bar, which I can write like this. You know this notation for the angle between the two vectors x bar and y bar. And therefore I can write cos theta is equal to x bar dot y bar upon mod of x bar into mod of y bar. That formula to find the angle between the two vectors. Here, what is x bar and y bar? Here x bar, you know, it is x minus alpha, y minus beta and z minus gamma, and y bar is the direction of the axis which is LMN. Okay, so putting the values in this, what I will get is cos theta is equal to x minus alpha. Let me write. Cos theta is equal to x minus alpha, comma, y minus beta, comma, z minus gamma, dot L, comma, M, comma, N upon mod of this x bar and y bar. So it is a square root of, or let me write, mod of x minus alpha, comma, y minus beta, comma, z minus gamma, okay, into mod of this L, M and N. Okay, let me call this as star. Now simplifying, we'll get the required equation. This implies what I will get is cos theta is equal to, this is the dot product of the two vectors, say x1, x2, x3 and y1, y2, y3. So x1, y1 plus x2, y2 plus x3, y3. So L into x minus alpha plus M into y minus beta plus N into z minus gamma is the numerator. And what is the denominator? The magnitude of this vector x minus alpha, comma, y minus beta, comma, z minus gamma is given by square root of x minus alpha square plus y minus beta square plus z minus gamma square into square root of the magnitude, square root of L square plus M square plus N square. So it is L square plus M square plus N square. Okay. And squaring both the sides and simplifying, we get, so if you square here, this square I'm writing here on this side, L into x minus alpha plus m into y minus beta plus n into z minus gamma. This square, see cos square theta is equal to this square, and these two square roots will go. And if you take the cross multiplication, you will get this thing, what I am writing here. So is equal to, say, cos square theta into, say, L square plus M square plus N square into x minus alpha square plus y minus beta square plus z minus gamma square. Okay, and this is the required equation of the right circular cone. So this is the final equation which you must remember. But as you know that, or you can see that this equation is very difficult to remember. So what you can do is just remember this star. That's why I have kept this star. To write down the equation of right circular cone in any problem, just remember this simple step. Cos theta is equal to x minus alpha y minus beta z minus gamma. And after putting this, you can simplify that equation, and that is more easier way to get your solution of that problem. So we'll see in the problem that how I can use this this step to write down the equation of right circular cone. So fine. Now as a corollary to this theorem, we'll derive some special cases. Say corollary number 1. In the above theorem, if the vertex of the right circular cone is the origin say 0 0 0, that is v equal to 0 0 0, then its equation equation of the right circular cone is obtained just by putting alpha beta gamma 0 0 0, because in our theorem alpha beta gamma is a vertex. So what I will get here is this equation, say L into x plus m into y plus n into z whole square. Alpha beta gamma is 0. This is equal to cos square theta into L square plus m square plus n square into x square plus y square plus z square. So this is the equation of right circular cone whose vertex is the origin. Another corollary we can say, these are all special and simple cases which are very useful. If the vertex is the origin 0 0 0 and the axis is the x-axis of a right circular cone, then its equation is given by, we have already obtained the equation of a right circular cone with vertex origin. So I can use this equation. What I should do is just put the direction of the axis. You know the direction of the axis is given by L comma M comma N in the theorem, and here the axis is the x-axis. So the direction will be 1, 0, 0. So I can write directly by putting L equal to 1, M equal to 0 and N equal to 0. Let me write just for a reference that take L equal to 0, taking L equal to 1, M equal to 0 and N equal to 0, because it is the direction of x-axis. It is the direction of x-axis. So LMN is 1, 0, 0 respectively. What you will get is 1 into x plus 0 plus 0. So simply x square here is equal to cos square theta. Again here it is 1 square plus 0 square plus 0 square, so simply 1. And this will be x square plus y square plus z square as it is. So simplifying this, what you will get is sec square theta into x square, take dividing by cos theta, assuming it is not 0, and it is in fact not 0, we'll get x square plus y square plus z square, and that implies x square into sec square theta minus 1 is equal to y square plus z square, which is nothing but x square into tan square theta is equal to y square plus z square. So the equation of a right circular cone, finally I can conclude as y square plus z square is equal to x square into tan square theta when the axis is the x-axis and the vertex is at 0, 0, 0. Similarly, we can write down the second result. I am writing in short, just replacing this coordinate number 2 if the vertex is origin and the axis. Only the difference is if the axis is y-axis and vertex is same, is the origin, then the equation of the right circular cone is in the same way can prove as say x square plus z square is equal to y square into tan square theta. Okay, so when the axis is y-axis and vertex is the origin, and finally the equation of right circular cone, so this is called number 3 and this is 4. Equation of the right circular cone when the axis is the z-axis and vertex is again the origin. This equation will be y square plus x square is equal to z square into tan square theta. So this is the equation of a right circular cone whose axis is the z-axis and vertex is origin. Okay. Even if some addition to this, suppose the angle is given, theta is equal to say pi by 4, then this becomes even more simpler equation. Say, let me write this way, another corollary. If the axis is z-axis, vertex is origin, and the semi-vertical angle theta is pi by 4, then the equation becomes, what you have to do is just put theta equal to pi by 4 here. So what you will get is the equation of this right circular cone x square plus y square is equal to z square, because tan pi by 4 is 1. So equation of right circular cone is also can be written in this form, is a special case. Let us solve some problems based on these equations. Examples. The first one, obtain the equation of a right circular cone whose axis is the line given by the equation x is equal to y is equal to z, and which is passing through, means this cone is passing through, and the cone is passing through a line 2x is equal to 3y is equal to 5z. Okay. So what is given to us can understand like this, that there is one axis of the cone whose equation is x is equal to y is equal to z, and the cone is passing through this line 2x equal to 3y equal to 5z. So cone is passing through means the whole line is on the cone, and we know that every line is on the cone is a generator of the cone. So this is one generator of this right circular cone, and the intersection of the generator, any generator, and the axis of the right circular cone is always a vertex. So if I consider this line as 2x is equal to 3y is equal to 5z, then this gives me the vertex as a point of intersection, and it is obvious that the intersection of these two equations, these two lines, is 0, 0, 0. By observation, you can see that 0, 0, 0 satisfies both the equation. So origin is the vertex. So let us begin by mentioning that it's clear that the vertex of the cone is 0, 0, 0 because it is the intersection of the axis and the given generator So we are writing directly that intersection is 0, 0, 0. Now to find the equation of the cone, we need those values alpha, beta, gamma, etc. Okay, and value of theta also. What is the angle theta? Angle theta is the semi-vertical angle that is not given in the question or in this problem. So we would like to find theta, or say cos theta value, which is required in the equation of the cone. This theta is the angle between say this direction and this direction. So direction of this x, y, z, okay, is given as say 1, 1, 1. You can see here is 1, 1 and 1. You can understand like this. So this is 1, 1, 1, and this direction of this generator, which you can write this equation as, let me write here, the generator that is 2x is equal to 3y is equal to 5z, I can write as, taking the LCM of 2, 3 and 5, that is 30, and dividing this equation by 30, what I will get is, say x upon 15 is equal to y upon 10 is equal to z upon 6. So the direction of this generator you can take as 15, 10 and 6, or one can take the direction as x upon 1, means by writing this equation in a different form. I am showing you another way. X upon 1 upon 2, y upon say 1 upon 3 and z upon 1 upon 5. But we do not want to work with fraction, so I am writing this in the integer form by dividing the whole equation by the LCM 30. Okay, so we have the two directions, direction of the generator and direction of the say axis. So let me mention that here the direction of the generator is, say, x bar is equal to 15, 10, 6, and the direction of the axis is, say, y bar is equal to 1, 1, 1. It is here. Okay. So therefore, the angle, semi-vertical angle theta is given by the angle between these two vectors according to our definition. So the semi-vertical angle theta, therefore the semi-vertical angle which is not given to us, semi-vertical angle theta is obtained by the equation cos theta is equal to x bar dot y bar upon mod of x bar into mod of y bar. So that is just using this vectors, we get cos theta is equal to x bar 15, 10, 6 dot 1, 1, 1 upon this thing 15 square plus 10 square plus 6 square into 1 square plus 1 square plus 1 square. So this is nothing but 15 plus 10 plus 6 upon this is say 225 plus 100 plus 36 into 1 plus 1 plus 1. So simplifying, what you will get is cos theta, value of cos theta is equal to, here it is 15 plus 10 is 25 plus 6, 31 upon this thing, square root of 325 plus 36 is 361 into root 3. So finally this is nothing but 31 upon 19 into root 3. 31 upon 19 into root 3. We cannot find the value of theta, and actually we do not want the value of theta also in the equation, because we have the equation of right circular cone. We know the equation of right circular cone as Lx, means right circular cone with, let me write equation of right circular cone with vertex. Vertex is given here 0, 0, 0. I mean vertex you obtain. Vertex 0, 0, 0 is the Lx plus My plus Nz whole square is equal to cos square theta into L square plus M square plus N square into X square plus Y square plus Z square. This is I am writing from corollary number 1. Okay, you can see that and verify. So what I need to prove is, what I need to substitute not the theta but only the value of cos theta. So I can write cos square theta here. So this implies, let me write this way, here this L is equal to 1, M is equal to 1 and N is equal to 1. That is the direction of the axis of the cone. Okay, and cos theta is 31 by 19 upon root 3, which we have calculated because of 1. So putting all the values, what I will get is, say, x plus y plus z whole square is equal to 31 square upon again 19 square, that is 361 into 3 into 1 square plus 1 square plus 1 square into x square plus y square plus z square. Okay, so just simplifying, we'll get the equation of the cone. Okay, so this is our final answer. So whatever the answer you get, you can calculate, and that is our final answer. If you want the answer, you can write this as 31, and this is say 1083 into x plus y plus z whole square is equal to this 961 into x square plus y square plus z square. That we can check. This 3 will be, just a minute, let me check. I think it is not proper. This 3 will be cancelled with this 3, so it is not this way. Just what I have to do is I should find what is 31 square. So 31 square is 961. Okay, so what I will get is this 3 and 3 will cut, and I will get 361 into x plus y plus z whole square, okay, is equal to 961 into x square plus y square plus z square. Is that fine? Yes. So this is our final answer. This is the required equation of the right circular cone. Let us take another example of a right circular cone. Say, obtain the equation of a right circular cone whose vertex is 0, 0, 0, semi-vertical angle is pi by 4, and the axis is x is equal to minus 2y is equal to z. Okay, so first I start by writing the equation of a cone, right circular cone. We know the equation of right circular cone. Equation of the equation of a right circular cone with vertex 0, 0, 0 is, it is the same thing what I have written here. It is this equation. So I'll be writing Lx plus My plus Nz, Lx plus My plus Nz whole square is equal to cos square theta into L square plus M square plus N square into x square plus y square plus z square. Okay. Here theta is pi by 4. We are given that theta is equal to pi by 4. So cos theta is say 1 upon root 2, because cos pi by 4 is 1 upon root 2. And the axis is given, and axis of the cone is given as the line, say x is equal to minus 2y is equal to z, that I can write as x upon say 1 is equal to y upon minus 2 is equal to z upon, or rather I should write y upon say minus 1 by 2, taking the 2 in the denominator, and z upon 1. So L, M, N values are, means the direction of the axis is 1, minus 1 by 2 and 1. So putting all the values, what we can get is, that is x minus 1 by 2 y plus z whole square, putting L, M, N values. Cos theta is 1 by root 2, cos theta is 1 by root 2, so cos square theta is simply 1 by 2 in this equation. Then again 1 square plus 1 by 4 plus 1 square is 1. 1, L is 1, M is minus 1 by 2, and this is 1 again, into x square plus y square plus z square. So we get this equation. Just to simplify this, so I can take the LCM and write the equation as 2x minus y plus 2z whole square into 1 upon 4, and here I can write this as, so this is 4 plus 1, 5 plus 1, 6 by 8, 6 by 8 into x square plus y square plus z square. So 6 by 4 into 2 is 6 by 8, and cancelling this we'll get 2x minus y plus 2z whole square. So 4 2s are 8 and 2 3s are 6. So we'll get 3 times x square plus y square plus z square. So this is the required equation. You can simplify and write the equation in the expanded form. So this way you can solve the problems of right circular cone. So this, we come to an end of this lecture. Thank you.